In this video, we are continuing our final exam review, and we will look at improper integrals and how to set them up. So there's two ways that a definite integral can be improper. The first is if one of the limits of integration is infinite. So that can happen if a is negative infinity and or if the upper limit b is positive infinity. So that corresponds to the situation where our interval from a to b is infinitely long. The second situation is if our function f is discontinuous somewhere on the closed interval from a to b. Those are the two ways an integral can be improper. So next, I want to look at a few examples of how I would begin the process of setting up improper integrals and writing them as limits. So with this first integral, it's improper because of the negative infinity. So what I would do is I would replace that negative infinity with a variable like t, keep the rest of the function the same, e to the 1/4 x dx, and then I take a limit. I take the limit as t approaches negative infinity. And that's how I would begin the process of evaluating this integral. Okay, so what I want you to do next is pause the video for 2 minutes to try setting up the next two integrals in that form. Get it to the point where you can express it as a limit, but don't actually evaluate it. 4, 3, 2, 1, pause the video. Pause it for 2 minutes to really try these. All right, so let's go ahead and talk about them together. So with that next integral, what's making it improper is the fact that this is discontinuous at x equals 2, because that makes my denominator 0. All right, so what I need to do is this time replace the 2 with a variable like t, keep the rest the same, so 0 at the bottom. My function is 1 over x minus 2 dx, and I'll need to take a limit. But for this limit, to help me think about how I would write it, I'm going to draw my interval from 0 to 2. And t, my variable, needs to be getting really close to 2, but from within this interval, because we're in the interval from 0 to 2. So that means we're in the interval getting really, really close to 2, which means we're approaching 2 from the left. And that's how I would set it up as a limit. All right, let's move on to the next one. We got this integral from 0 to infinity of e to the negative x over x. So there's two reasons why this integral is improper. One is the infinity, and the other reason is that our function is discontinuous at x equals 0, and x equals 0 is part of the interval from 0 to infinity. So I can only deal with one improper thing at a time. So if there's more than one improper thing, I need to split up my integral into two pieces. So I'll go from 0 to something, e to the negative x over x dx, and then plus another integral that picks up at that number to infinity, e to the negative x over x dx. And I could pick whatever I want for that number that goes in the box, as long as I pick the same thing in both spots. So I'll pick something simple like 1, but if I wanted to choose something different like 2 or 5 in both of those spots, I could. All right, and let me just write one of these integrals as a limit, and I'll leave the other one for you to try. So this first integral from 0 to 1, what's making it improper is the 0. So I would replace that with a t. Then I have a 1 up here, e to the negative x over x dx. And we need to take the limit as t approaches 0. But if I think about my number line, this time it's from 0 to 1, and I got to stay within the interval, and I'm approaching 0, which means I'm getting close to 0 from the right-hand side. So 0 from the right, I put a little plus sign there. And this other integral is going to be, I'm going to leave this for you to try. Try this one. All right, so one more of these. All right, so I got the integral from 0 to 4 of 1 over x minus 2 dx. So one more time, I'm going to ask you to pause the video just for 1 minute this time. See if you can set this one up as a limit. 4, 3, 2, 1. Pause that video. Pause it for just a minute this time to try this one. All right, so hopefully you've done that. Hopefully you paused it for a minute to really try this. So this time our function is discontinuous at x equals 2. And the key thing to notice is that that value is in the middle of the interval. As opposed to before, when it was discontinuous somewhere, it was discontinuous at an endpoint. The previous two functions were discontinuous at endpoints of the interval. So when it's discontinuous in the middle, I also need to split it up into two pieces. So I'm going to put a little dividing line here. I got to split it up into two pieces. Going from 0, let's write that better. One integral going from 0 to that place where it's discontinuous. The 2, 1 over x minus 2 dx, plus the next integral goes from, starts at 2, and then goes into a 4 of 1 over x minus 2 dx. And that would be how I set it up. And from here, we would write both of these with limits in the same sort of way we've been doing it with the integrals above. So in the next video, we will do an example evaluating an improper integral.